Now, today we are going to see how to create symbol table, latching circuit, and variable table. Okay, and we also see the flasher byte. Okay, now first of all we see the latching. So what is latching? Latching means holding your output. Okay, here for example we are having toggle switches and push buttons. Toggle switch means you can make the switch on off manually, right? When you make the switch on, your input remains on. With that, your output also remains on continuously until you make the switch off, right? In case if you are using a push button means momentary switch. Okay, means when you press the button, your input is on. When you release the button, it becomes zero again, right? So that is a push button. Means when you press and release, your output should remain on until you give the another push button for stop, right? So here for making that circuit latching, here you can see I'm giving the input address. Okay, let's minimize this windows and output address here. Okay, now one input, one output. If I'm using a toggle switch, I can use this circuit. But if I'm using a push button, I must use latching. For latching, take one NO in parallel. Okay, in parallel. Here we have to give the same output address, which is going to be 1. Okay, when you operate input. Okay, take the same output address. So let's see how it works. I download the program and monitor. Now, from simulator, you can see when I operate the input here I0.0, the output is on. This output, the same output status here we are taking in parallel to the input, right? So here this is also on. So when I release the button, it becomes 0 in hardware. The status is 0 here, right? Your output is still on here. Means it is holding its own status. This is called holding or latching. But if I give the same input once again, what is happening? Nothing. The output is still on. It is not going off, right? So this is called a logical continuity here. Okay. So this continuity we need to break. For that, we are using one NC here for breaking, say I0.1. Save it and you can download monitor. Now, so when I give this second input here, say second push button. Okay, one push button for start, one another push button for stop. Okay. So when I give this input, right? So here I'm toggling here 2 times. Start button, press and release. The output is on. For stop, press and release. For stop. Okay, you can see this breaking this continuity. So the output is going off here. So this output status here also it goes off. Right? So this is your latching condition for a push button. Okay. Now our next topic is symbol table. So what is symbol table? Symbol table means here we are creating a list of inputs and outputs because we are having many inputs and outputs here which we cannot remember for which task we are using, right? So I can give some names, okay, for these inputs and outputs. So here for creating symbol table, go to the options here on toolbar, symbol table. You can see it has opened a symbol editor here. In this, you can enter your symbolic name. Okay, you can see status, symbolic symbol, address, data type, etc. So here I give the name like start, address I 0.0. So data type is Boolean. Boolean means digital, true or false. True means 1, false means 0. And if you want, you can do any comment also, like start command from motor 1, etc. From motor something. So next address it will take automatically here. Okay, here stop. Okay, so when I give the next symbolic name motor, it is showing under address, right? But for motor, we are having output address, right? Q0.0. So you can change the address here. Okay. Okay. Motor for conveyor something. Okay. But one more thing is this information is only for our understanding. Okay. Here this name, start, stop, motor, and comments are not downloaded into the PLC. Now, here these symbolic names and comments are not downloaded into the PLC. It is just for our information. Okay, because your PLC is not having that much of memory to store all this text. Okay, now so here this way we can easily understand for which command we are using I address, Q address, etc. Okay, it is about the symbolic name. Here we are creating a list of the inputs and outputs using symbolic names. Okay, now next topic is variable table. Variable table means here you can monitor and modify I address, Q address, M address, and data block memory address. Okay, in variable table means here suppose we are having some networks in our logic. We are having some network 1, 2, 3, 4 like that. We are having many networks. So suppose I am having 50 networks, 60 networks. So there are many input and output status, right? So if I want to see the logic, I need to scroll up this window and down, right? It will take more time. Until then, your output status might be changing, right? So it is not easy to monitor your logic here, right? So what we are doing, we are using variable table where I can enter the input or output address, whichever the status I want to monitor. So here, let's see how to create variable table. For that, go to Schematic Manager. Now project blocks, right click on that, insert new object, variable table. Here you can see the name is VAT1. Okay, VAT1, VAT2, VAT3 like that. You can create many variable tables. Okay, like I'm having many machines. Okay, machine 1, 2, 3, 4 like. Okay, for each machine I can create a separate variable table. And you can give the name for that variable table like symbolic name. I'm giving machine 1. Say okay. So this is added here. Okay. Now you can double click open this machine 1 variable table. Here it is. Just zoom in. Now, so here whichever the address status you want to monitor, enter that address here. Okay. I 0.0, 0.1, 2, 0.0. Now, to monitor the status, on toolbar you can see we are having spec symbol. Okay. So when you select this, here you can see the status variable value here. false. Okay, initial value will be always false. Now, so when I operate the input here, you can see when the input is operated 0.0, is showing you the status here, green, that is true, right? For a push button, when I release, this is off. But your output is still showing true, right? When I do the stop, second input, stop. So this is how we can see the status of your input and output here by entering the list of IOs. Okay. So no need to check in your OB1 where networks are there, right? Many networks are there until you scroll up or scroll down. Status of that logic will be changing, right? It's not easy to monitor here, right? So for that we are using variable table. Here you can see there's one more option called modify variable. That means we can modify the status of your input output or bit memory. But generally for I and Q address we cannot modify. You can only monitor the status here. To modify this status, you need to go to variable. We're having display force values. This option is available only when you are connected with hardware. In simulation, we cannot do this. Okay, we cannot use this force here in simulation. We can use only with the hardware. Okay, that's why it is disabled. Now, suppose if I want to modify some bit memory address, I take that in a next network here. Here I give the address M0.0. It's a bit memory address, right? Then for the output U0.1. Now, so there is no command for M0.0, right? It's internal memory, bit memory of PLC. For I address, we are having signals, right? I and means push button switches that will be there in the hardware. But for M, it's an internal bit, internal memory, which is not connected to any switches, right? So to operate this, instead of this, I will take another memory. 1.0, 1.0. Enter what I did. Now, so it is not on, right? So from variable table, here I enter the address M1.0 and Q0.1. Okay. Now go to online monitor here. For M address, modify variable, modify value, enter value 1 means we have to update the status to true 1. This is a digital address, right? So I'm taking it as a true. Now, when I click on this button, modify variable, you can see it is showing green on. If I want to make it 0, off, then click on modify. Then only it will change the value. Until you press on this modify variable, it will not change the value. Okay, this is how we can modify M address status and DB address status easily. But for changing the I or Q address, we should use forcing option, which is from display force values. Okay, you cannot force this like Q address directly. See, when I give 1 here, I release this one. For Q address, when I give true, is it changing? I press this one. Is it changing? No. For Q address, we cannot change. For I address also, we cannot change. Okay, we cannot modify. Only M address we can modify from this. Now, so this is about the variable table. Next, our next topic is flasher byte. Flasher byte means here flasher means flashing, okay, on off flashing for a predefined time, like fast flashing, slow flashing, medium flashing, right? So there will be LEDs on panel that they will be flashing for showing the status of your logic, right? The motor is on or off, or if temperature has crossed the limit, okay? So for such process, we are setting the flashing, okay? So how to set this flasher? For that, go to the hardware configuration. In this, we are having a CPU, right? Double click on the CPU. Here we are having clock or cycle, cycle or clock memory. When you select this, at the bottom, you can see clock memory. Initially, it will be disabled. Here we need to select this option to enable memory byte. So here memory byte like MB0, MB1, MB2. Okay. So MB0 means memory byte 0. Okay. So that byte number 0 we are taking here. So for this byte we are having 8 bits. For this one byte we are having 8 bits. Right. So each bit is flashing with different timing. How to know that? Select here byte number 0. Then press your F1 keyboard, F1 button on keyboard. It opens help file. In this help file, you can see clock memory option. This clock memory, you can see periodically. Here we are having bits 0 to 7. In byte number 0, we are having 8 bits 0 to 7. So here you can see period duration is in seconds. If I select bit number 0, it is flashing with 0.1 second. Okay, 0.1 second means this is the frequency. In 1 second, it is flashing 10 times. That means frequency means number of times it is flashing. Right. So in 1 second, it is flashing 10 times. Whereas if I say like M0.5, bit number 5, if I take, it is flashing with 1 second. Means for every 1 second, your lamp will go on or off. Okay. So by selecting the bit number, we can select the delay, means flashing delay. Okay. So let's see that example. After selecting this, activating this clock memory, say okay, save it again, save and compile, and then download this. So okay, yes. Now here I will change the bit number to 0. Save this, download, and check it one time. You can see here this flashing faster, means in 1 second it is flashing 10 times for bit number 0, M0.0. Okay. If I want to use it for another memory, like here I give M0.5 address to 0.2 something, download, save. You can see this flashing for every 1 second on off. So, for example, I want to know the status of the motor on a panel. We're having LEDs. For that LED, I want to flash, right? This motor Q0.0 is connected to a motor, okay, hardware. Whereas Q0.2 I will use for lamp indicator for showing the status of the motor, whether the motor is on or off. So for the flashing in parallel means for one lamp I am having two conditions, either flash or steady on, continuously on. So here I download this. Now here you can see motor status is off, right? So it is flashing. So this lamp indicator is flashing. So when I make the motor on, you can see the same lamp is steady on. It is not flashing now. Whereas this bit will be flashing because the task of this bit is to flash. Okay. Now if I do stop again, motor is off, so it start flashing. So we are having one lamp indicator, okay, for motor status. When motor is off, it should be flashing. In other case, like I don't want to show flashing if the motor is off. I want to show the lamp is off state even if the motor is off. So here I take the output in series with the flasher. Okay. Another example. Right now you can see motor is off, so it is flashing here, but your output is still off. Okay, this is lamp indicator. Now when I do the start, when motor is on, then only this will be flashing. Means when motor is on, the lamp indicator will be flashing. If motor is off, the lamp indicator will stop flashing. No output. Okay, so this two methods we can use for displaying the motor status. Okay, using flasher bits. Okay, so this is how we can make the logics in a process. Okay, for different applications.